This is a video lesson for the beginning of rational functions. We're in a new unit now. We're just going to start by graphing a few basic functions. A rational function is when you have x in the denominator. So what we have is 4 over x in our first example, and obviously x is in the denominator. We've not dealt with this yet. If you remember, a negative exponent means the reciprocal. So another way that this can be written is 4 times x to the negative 1. So in other words, what we're dealing with now is, what do I do when I have exponents that are negatives? Well, an exponent that's negative would be written like this. And so this whole unit is going to be dealing with what happens when I have x in the denominator. They're going to get a lot more complicated than this. We really won't see this format. Again, a lot more complicated than this, but this is what we're going to be starting with. So today should be pretty easy. We're going to be just filling in a table, and I'm going to give you the x values, and you'll see in the homework problems the x values will be listed that you should be using for your table. So I have these x values from -8, -4 to all the way up to 8. And the first thing you're going to do is use the x values that I'm giving you to make an xy chart. So we're just dealing with 4 over x. So -8 divided in the denominator, so 4 divided by -8 would be -1/2. 4 divided by -4. If x is -4, 4 divided by -4 is -1. 4 divided by -2 is -2. 4 divided by -1 is -4. But then we get to 0, and as I type 0 in, 4 divided by 0, well, I can't divide by 0. We know that anything divided by 0 is undefined, so nothing exists there. Why is nothing existing there? It cannot reach that particular number. You see, the issue with rational functions is that if x is in the denominator, anything that gives you 0 in the denominator will then be undefined. So this is actually going to be one of our asymptotes. We'll talk about that in a moment. And again, 4 divided by 1 is 4, 2, 4, 8. These are pretty easy to get. You can use your prism to help you. Next, you're going to graph these. So you're going to plot all these points. Obviously not the 0 because that's an asymptote, but you're going to plot each of these. I did it on the prism and I just copied the image over. You'll be doing it on your notebook paper. And you can see I have all 4 points labeled here. And you can see what's happening is as it increases, it's curving, and going down. And what's going to happen with these graphs is it's going to go down forever. It's infinitely decreasing, so it's going to approach negative infinity. But as soon as it hits 0, the axis, there's nothing there. And then all of a sudden, as soon as I get to the positive side of x, it's no longer down at negative infinity. It picks up at positive infinity and then comes down and curves. And that goes towards infinity. So it's approaching infinity in multiple ways. Towards the negative x-axis, it's approaching negative infinity on the x-axis, positive infinity on the x-axis. It's approaching positive infinity this way, and then negative infinity this way. So it's following multiple asymptotes. We're going to talk a little more about where these come into play and where these are applied and how these behave. One of the most useful functions we talk about, also one of the most complex. A very quick example. Let's pretend for a moment that you have a vacation house that you're going to, and it costs, let's say the 4 represents $4,000. Really nice vacation house. Well, if you go by yourself, 4 divided by 1 means you're going to be paying $4,000. But as the denominator gets bigger, you're going to be taking that cost and breaking it up. So if you invite 2 people with you, now each of you are only paying $2,000. Invite 4 people, now you're each only paying $1,000. Invite 8 people, split that cost between 8 people. Now you're each paying half $1,000 or $500. And that's in essence what this comes down to. Now, the last thing you're going to do is you're going to identify the asymptotes. There's going to be a horizontal and a vertical. Now for now, there's only going to be one of each. That will change and get more complicated. But for right now, we're going to identify the asymptotes. And one of them is going to come in from your chart. 0 does not exist. right here at an x value of 0, when x equals 0, this vertical asymptote, remember vertical lines are x equals a number, this vertical asymptote, x equals 0, is one of them. But I also see it's following another asymptote. This one has two asymptotes. It's getting infinitely closer to 0 down here, and it's also getting infinitely closer to 0 from this side. So that means there's a horizontal asymptote at y equals 0, which is the x-axis. So there's a vertical asymptote at 0, x equals 0, horizontal asymptote at y equals 0. Let's take a look at the next one. We've got a little bit more going on. We have a couple of transformations and shifts. First of all, this is going to be flipped upside down because there's a negative in front of the 4. This means it's moving right 3 and up 2. Now, you don't need to know much about transformations right now. Don't worry about it. Just wanted to make a connection to something that we knew. And again, I've provided the x values. -5, -1, 0, 2, 3. Notice I put 3 in the middle. That's going to be our asymptote. And that's because if I take 3 minus 3 in this denominator, that's going to give me 0 in the denominator, which again is impossible. It's undefined. So we put those in, and I'm going to show you where I put them in the calculator, just in case you need help with that. I entered in the function. It looks like this. Click draw, and I moved my window already. You can adjust your window however you see fit, and you can see that right there. If you want to get those points, I can hit trace, and I can just type in the points. The first number in the chart was -5, so I type in -5. There it is, y equals 2.5. Next number is -1. And then I get 3, and I can get all my points that way. You could also get your points for your chart off the table app. So inside the table app, and I can go right from here, -5, -1, and I can get all of my points that way. And again, you can see 3 gets an error. Why does 3 have an error? Well, because that's going to be our asymptote. 3 gives me 0 in the denominator. And I made a full graph already and copied that over from the Prism. So it should look something like this. And the asymptote then, okay, so where is it following? This is going to go infinitely closer to an x equals 3 asymptote. So here's 1, 2, 3. Here's x equals 3. And this side is infinitely close, approaching 3. This side is infinitely approaching 3, but neither one of them will ever actually touch 3. At 3, it does not exist. So the vertical asymptote is x equals 3. Again, the vertical you'll get from your chart. But where's the horizontal asymptote? What is this getting ever closer to? It's getting closer and closer to, on both sides, a 2 on the y-axis. This keeps getting closer and closer to 2. This side also approaches 2. So the horizontal asymptote is y equals 2. Now I can actually see these straight from the equation. The denominator, 3 minus 3 would give me 0 in the denominator. So that's why it's x equals 3. And it moved up 2. So the asymptote moved up 2 with it also. So y equals 2 matches the function as well. You have 3 practice problems on another document. They look like this, and again, as I said, I give you the x values that I want you to use. Please use those in the chart. One other note about the instructions: you're going to do this on a piece of paper because there's graphs involved, and take a picture and submit the picture. Some of you make very neat, really well done graphs, clear, easy to see. That's great. Some of you do not. I have to be able to make it out. Your graph has to be easy to read, has to be neat. If I can't make out what's going on in your graph and it just looks like scribbles, I'm not going to give you credit for them. So please be very detail-oriented with these graphs. Take your time with them, make sure they look right, make sure the tables are well done.